Dear students, first you need to download and install the Vrep program, which you can find in this website. Now, usually the Vrep program does not come with the Kilobot robot models. For that reason, you need to visit the main web page for the Kilobot robots on the K-Team website. This is the address here. And as you know, here we have the introductions, specifications, software, menus, etc. Now you need to click on the software, sorry, not the software, the downloads. And here you need to select the Kilobot model for Vrep simulator. You can also download the Kilobot scenes. I will just show the model part. Here I have different models. This is for the robots, for the control, and this is for the light intensity. So I need to download all of them. And after I download them, I need to find the folder for my Vrep installation. This is a folder. And on this folder, there is this another folder called models. Click on models, click on robots, click on mobile robots. Although the Kilobot controller and the light intensity are not mobile, so you could also put them into non-mobile, but for convenience I will put all of them to the mobile category. After you did this, you can then open up your Vrep application, which is here. So let me just pull it out. And when you open it, you will see a blank space like this. Now, in order to, and on the left hand side, you can see your browser for these objects like nature, office items, etc. Here we are interested in robots, of course, and under the robot category we have different mobile robots. Now here you of course you should select the Kilobot and place them onto the platform, so it will complain that it's not up to date, etc., but it will work. And since Kilobots are very small robots, they will look very small at the full zoom out, so you need to zoom in a little bit. Now this is very good, but you need one more thing to be able to run these simulations. You need to put the Kilobot controller to the scene, to the environment. Because in real applications, of course, we are going to program this with the Kilobot controller. So I will put this. Now it's an overhead program, so it will appear here. But that, after you place this, you can forget about the controller. Now we can focus on the robot. So for instance, a very simple, like what happens if I do run. So I'm now running it. And here I have a menu for the Kilobot controller at the top. So it has run, pause, charge, battery voltage, and reset buttons. So charge and battery voltage are about the battery management. Now, but I want to run the program. Okay, so here is my robot at the bottom, and I want to run this. Now I will run this. It won't work. The reason it doesn't work is it's away from the overhead controller, so I need to move this robot to a close by position. So I will take this. So the robot doesn't receive the original command. So now this is closer, so I will run this again. Now see, the robot starts to run. So before it was a little away from the overhead controller the first time, so that's why. Okay, so it's running, so I can pause this and I can put other robots here. Okay, for instance, it's showing that it's under the command of the overhead controller. Oh, actually, I should have stopped the program. Now, if I do run, it will run, but it's not really proper because I cannot update the program on these robots. To update it, first I need to stop the simulation. And as you can see, when I stop it, the two robots that I put later on, they are removed from the simulation. So for this reason, I should do my changes, not when it is running, but I need to stop the simulation first and do whatever modification I need to do. So I will put another robot here. Okay, so let's just use these two robots for our example. Obviously you can put more and you can put objects that they will interact. So if I make them run, they will run. Pause. Now I can also control their battery voltage. Green means it's full battery, and I can even simulate the charging for these robots if I do charge. And if I do run, they will just run. Pause. Okay, so how do I change the code here? This is very important. So first I need to stop the program, before I make any modification. Now on the left hand side, on this menu, you can see that we have the different objects, different entities. So kilobot controller, kilobot robots, number 0 and number 1. For instance, if I want to change the program for this one, I can open up. So again, I will show you, this is the script option, these are. So like if I open up this, I can change the script of this. And it is the same with the actual script that you are going to use with these robots. So here is where the user program goes. So the user program goes below. So what this is doing is it is basically setting the two motors, the right and the left motors, to the same values. So instead of using them, so if they have the same values, the robot will go straight. But I can do something like 200 and 0. Then control save, then close this. Now if I run the simulation, now you will see that the robot that I didn't touch, it's moving forward. Whereas the other robot, it is making a clockwise motion. See, this is how you will change the code. Okay, so let's see it one more time. So I will run the code. And I can increase the speed for the simulation. And you can see one of them goes straight. The other just makes a circular motion. Okay, good. So I'll just pause this and stop the simulation. Now one more feature about the program. Now as you know, these robots contain sensors to sense the other robots nearby. And in this case, in the user program again, so this is the user program part, here where I set the clockwise motion. And you can see that there is also a distance option, so a distance function. So this function basically gets the distance to the nearest other robot, where it can detect with the infrared emitter of the other robot by detecting the infrared light from the other robot. And the distance measurement, it can measure the distance, and depending on the distance, it will change the color of the LED on the robot. So the robot will blink in different colors. For instance, if the distance is between smaller than 0.09 units, then the robot will turn violet. If it is smaller than 0.08 units, it will turn to blue, etc. So let's see how it happens. So in this case, I will just select this robot, and I will click this one to be able to move this. So I will move this to, for instance, here. Okay, so now let's run the simulation again. So run. So, and I will increase the speed a little bit. See, now they will blink, 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 and then they will even collide there. Maybe. And of course, this program also simulates the interaction between the objects. And because of that collision, that tangential collision, now the direction of this robot has changed, and you can also place, for instance, at primitive objects like a cube here. Okay, so it usually adds to here. So I can also, for instance, take this cube and bring it to in front of the robots and see like what happens to the robot. Oh, yeah, I moved the object. So let's see. So it's a very nice simulation program. So I should change my selection, and I can, for instance, see. No, it will miss it. So just put it to here, and let's see what will happen. So the robot will come to the cube, and I wonder if there is a sensing algorithm there. Here, see, like now it hits the obstacle, and then because of the dynamics there, it basically changes its direction and keeps rotating. Whereas the other robot, as you know, I hit it with the block effectively. It actually should be on the floor somewhere. So let's see what happened there. Yeah, see now it's tilted. It's not on proper orientation, but since the motors are still vibrating, it's moving like this. So it's basically simulating the physics. So good. So have fun with this before we start the actual laboratory sessions. And it's a very nice tool because you can basically check your coding simply by changing the code here. And then when you come to the lab for actual experiments, you will do a similar coding in the experiment.